Hello everyone, welcome back to CS3100 Data Structures and Algorithms. In this video, we will start learning the basic concepts and basic crucial ideas of this course. And the first one, problem, algorithm, and program. So if you are confused with all these terminologies, then this is a good time to refresh your previous knowledge. And of course, some of you might have learned those concepts from your programming two course, but it might be new to some of you. So the problem is a function or mapping of inputs to outputs. And algorithm is a recipe for solving a problem whose steps are concrete and unambiguous. Algorithms must be correct of finite length and must terminate for all inputs. This is an important idea. Algorithms must be correct of finite length and must be terminate for all inputs. So you might face like a unlimited loop or something. And if you say, well, my algorithm has an issue of unlimited loop, then you cannot say that is an algorithm because algorithm must terminate for all inputs, right? So algorithm is recipe for solving problem whose steps are concrete and unambiguous. It means if you cannot solve a problem, to solve that given problem, then we cannot call it algorithm. That's why it says algorithm should be concrete and unambiguous, and also it should be correct. And finite length, it should be terminate for all inputs, right? So a program is an instantiation of an algorithm in a programming language. So it's not about specific programming language, but a programming language. So I hope now you can tell what problem is, what an algorithm is, and what a program is. Okay, let's see the next slide. Okay, let's read this question. There is only one way that a given problem can be solved. A simple question, true or false? And the answer is false. There are many ways to solve a given problem. Of course, one might be more efficient than another one, or one might take more resource compared to another one, but still there are many ways to solve a problem and solve one problem. And what we try to learn here, we want to analyze the different time complexity of algorithms, and we want to choose the efficient algorithm, right? So you need to remember there are many ways to solve a given problem, and what we need to do, we want to choose the best algorithm to save resource, to save time, and for many other reasons. Okay, the growth rates. So what is growth rates? So that's why this is one of the reasons why we need to learn to choose the most efficient algorithm for our given problem. So we can face many different problem sets, and problems that like if you have like the n, and n is, if n is really limited, like 1 to 10, in that case, like for example, um they might require like a similar resource. It means the time or CPU calculation, whatever thing. But if n gets bigger, like 20, 30, 40, then you can see the resource, like how many times, how many calculations are required, right? So when n is 10 and when n is 100, you can see the numbers, like how they are different, right? So if you increase your n, the problem size, then depends on your algorithm complexity, the value will be really different. So I will give you another good example. So if you have like a for loop, right, n times, and if you have for loop here, and if you say it, let's say if you have two for loops, and how many iterations will do this one for how many iterations it will do? It will do n times, right? And but if you have two for loops, then how many iterations it will do? And it will do two n's of iterations. So if your n is 10, then actually that is 20 times of iteration, right? But if you have nested for loop, then what's the complexity of this case? That case is n multiplied by n times n, that means n square, right? So if your problem size n, if that is 10, then it will be 100 times of iteration, not 20 times of iteration. So if you can, you can have two separate for loops, but if it can solve that given problem, then this is a better way to do it, not this way. So sometimes you have to embed like a loop inside a loop, but we want to avoid that case because this n squares case, the that growth rate graph, it does not look great. So what we want to do, we want to reduce the size of the growth rates. And if you have a really small problem size, if n is 1, then this one is 2, this one is 1, right? But if n is 2, then this one is 4, this one is 4, right? So if n size is 2, then this algorithm and this algorithm, they have same efficiency. But if n is 3, then 6, then that is 9. 6 iterations and 9 iterations. Now it is different, right? So then from n, when n is greater than 3, then we can say this algorithm has a better efficiency. And that's why we need to understand the growth rates, to understand when this problem size can make a difference. So next question. The value of which of the following growth rate functions grows the fastest? So fastest means like which one is more like has a deeper slope. So you can say on square and O1 log base to n. So this case, this on is this linear, right? So we can say linear and n square and big O n, that is just like a flat, right? So this log to the base to n, if you see that one, if you see here, that is pretty slow. So with this graph, we can tell, well, this big O n square, that's the answer. So this case, we use big O, but from our textbook, you will learn the difference between big O and big zeta. But also you can find many data structure and algorithm books, they just using big O rather than using big zeta, because many cases the program, the algorithm, the time complexity is determined by the upper bound, and you will learn what upper bound is from the textbook. So if you find this big O, and you can find the big theta in the textbook, but many cases they use it in the same thing, but technically they are not the same one. But more details you can find from textbook. Okay, so the other question: the value of which of the following growth rate functions grows the slowest? So again, which one is slowest? So this is, I mean, I found some people, some students, they thought this is a kind of tricky question. So if you see this one, like ON, N square, it will be more, let me do it again. So linear, N square, and 1, and maybe low base 2 like that. So that case, which one is the slowest one? The answer is big O 1 because it does not move, it's steady, like it's here, it does not change. And some students, they say, well, it does not change, so how we can measure the speed, or how we can tell it is the slowest one? So but still it does not change the value, so we can say it can be slowest one. So if you face this question for your quiz or assignment, then this one is the answer because it does not move. It's constant. Okay, and this question, it's just like what we did here. So when the difference happens. So how we can solve this question? Unfortunately, you need to actually try it out. So we can say when n is 1, n is 2, n is 3, then if you cannot find any value, no integer value, then you can type none. So let's see the case. We want to, for the growth function 5n log n. So if we can just try it, and it's 1, that is 1, 2, 2, and you can calculate 5 and so 5 and log n, that is log 1, that is 0, so it will be 0, and 20 and 10, but n is 2, that is 2, 4, like 8, and that is 2, then that is 1, it will be 10, 40, and 20. So this case, the answer would be when n is 1. So that's how we can solve this question. And this the next one is same thing. What we need to do, we need to just start with when n is 1, and we can increase n is 2. But let's say it's 20, but we already calculated. When the 20n is the smallest one. So, well, n was, even when n was 1, the 20 is, or 20n is already 20. So that answer is none. So that's how you can solve this growth rate questions.